OABC is a trapezium. We can see the two parallel sides, with OA being 3 times as long as CB. OA, so the vector that goes along from O to A, is called A, and it's worth noting here that that means the vector here is going to be 1/3 of A. OC is equal to C. E and F are the midpoints of OB and CA respectively. We want to find OE in terms of A and C. OE is going to be half of O to B, since E is the midpoint of OB. So that's going to be a half of O to B is C plus 1/3 A. So we can see that that's a half of C and 1/6 of A. We now want to show that EF is equal to 1/3 of A. Let's think first about OF. So to go from O to F, we could go from O to C, and then halfway along the diagonal, CA. Now OC is C. Going from C to A is backwards along C and then forwards along A. So that's going to be C, take away a half of C, add a half of A, so that's going to be a half of C plus a half of A. Now we know that OE is equal to a half of C plus 1/6 of A, so that means that E to O is just the negative of that. So EF is equal to EO plus OF. So that's going to be negative a half C, take 1/6 of A, add a half of C, add a half of A, and we can see the C's will disappear, and a half take away a 6 is a third, so that is equal to 1/3 A. We now want to prove that CEFB is a parallelogram. So that's CEFB. We want to show that's a parallelogram. Now we already know that EF and CB are parallel and the same length. So we just need to do something with CE and BF. So think about going from C to E. We could go from C to O and then O to E. So that would be negative C, add 1/6 of A plus a half of C, giving us 1/6 of A, take away a half C. Then for BF, we could go from B to C and then a half of the way from C to A. So that's negative 1/3 A, add a half of negative C add A, and if we work that out, so negative 1/3 A, take away a half C, add a half A, is 1/6 A, take away a half of C. So we can see that the other pair of opposite sides, this one and this one, are also parallel and the same length, and therefore we have a parallelogram.